All right, thanks for being here, everybody. I know we're up against the keynote and low blood sugar levels right after lunch, so I appreciate you all coming out. I hope it'll be interesting. I'm Mitch Rubinstein. I'm the former Director of Mission Systems at Green and the co-creator of the Widow Mission Planning Application. You've heard that. Over the last 2.5 years, we successfully brought the Silicon Valley approach to the US Department of Defense and government problems, and that's what I'm going to talk about today, bringing time-competitive cybersecurity for critical mission applications. This is me. I basically have studied warfare and computers for more than 2 decades, so this presentation is basically a culmination of that. I hope you like it. If you are not already doing DevSecOps, you are dead in the water. In the context of cyber warfare, you are unable to maneuver and falling prey to attack. Most of the time, we don't even call it cyber warfare, we call it cybersecurity. The main distinction being that in cybersecurity, our actions are exclusively defensive, and yet to the adversary that's attempting to impose their will on us through the organized application of military force, it sure looks like cyber warfare to me, except where one side, us, isn't fighting back. And I realize that in this crowd, some of you aren't fighting back, but the rest of the folks, right? Now, we aren't going to get into cyber lawfare, but part of the challenge is that at the policy level, we're still wrestling with how cyber fits into grand strategy. The threats are hard to attribute and consist of both state and non-state actors. I say that sometimes cyber warfare looks akin to another form of warfare that we've seen in the past, that of privateers with a letter of marque. That might be familiar to some of us in the room. I did see a Navy captain out there, so you probably didn't. At any rate, this is really nothing we haven't seen before. But how do we deal with these cyber warfare threats now? Well, most government systems have an annual review of the minimum cybersecurity requirements to keep their authority to operate, or ATO. And when that review occurs, any gaps in cybersecurity don't even have to be fixed. They can be waived with a plan of action and milestone, or POA now, for which the software developers will get another whole year to fix. So if the 0 day is published at the right time, a program may have up to 2 years to patch a cybersecurity flaw. Now, I know I'm losing credibility with some of the US government employees in the audience. No, I would never give them a year to fix a critical flaw. You want to say to me, that's not how that works. You probably want to rebut me with the way things should be working, but I can only tell you what I've observed through my own lying eyes. So bottom line, with a 2-year cycle to address a gap in your cybersecurity defense, in other words, you are giving your adversary 2 years to outmaneuver you, you are dead in the water. The result is basically complete infiltration of our completely vulnerable cyber infrastructure, as evidenced by the plethora of high-profile exploitations you can read about on any given day. Some well-publicized examples featured on the screen, such as hostile cyber recurses sitting on our email for, you guessed it, 2 years. In fact, this inability to compete temporally is so bad that for the first time, the US government gave the FBI permission to hack into lawful cyber systems without the consent of the owner in order to fix vulnerabilities. It's hard to exaggerate what an escalation that is. As you may be able to tell from American news sources, many Americans are inherently allergic to the government telling them to do anything, even if it will keep them from getting sick. In this case, the US government is treating a symptom, but still not curing the disease. And in the bigger picture, government solutions tend to be some variation of the same thing, throw money at it. In fact, the Biden administration recently asked for $10 billion to fund government cybersecurity this year. So the question we're left is, will more money solve our problems? Historical precedent says probably not. Just last summer, the US Senate Homeland Security and Governmental Affairs Committee released their cybersecurity report, which found 7 federal agencies have not met the basic cybersecurity standards necessary. And by the way, this report follows its predecessor 2 years ago, which found 8 federal agencies failed to update system vulnerabilities, leaving their information open to hackers. So we remain vulnerable to small, more agile adversaries. And again, where have we seen this before? What can we learn from the history of small, technologically inferior militaries defeating Goliaths? Or in the words of one of my mentors, let's extract what has actually worked in combat and repeat that. Now, this lecture isn't trying to prove what works in combat. I believe John Boyd did that in his seminal works, A Discourse on Winning and Losing, Destruction and Creation, and Patterns of Conflict. So a refresher, or if you've never seen it before, John Boyd's theory of winning is based around the fundamental cycle of naturally organized actions. Whether a person or a team, they observe the environment, orient on the environment, decide on a course of action, and then take action. They then observe how the environment has changed, and so on and so forth. And these are the same in any form of human competition, whether our frame of reference is a wrestling match, air-to-air dogfighting, or indeed cyber warfare technologies. The key here is that we cannot predict the enemy, and the combatant with the ability to adapt to the unforeseen events of the battlefield faster will prevail. So in a nutshell, I ask you to agree with me that the way inferior forces win is by outmaneuvering the larger, slower military force. The essence of maneuver being to take action not to directly attack enemy forces, but to generate and exploit some kind of an advantage. It's always important to remember that maneuver is not just spatial. It can be psychological, technological, or temporal, and especially important is maneuvering in time. We generate a faster operating tempo than the enemy to gain a temporal advantage, and gaining that temporal advantage is so important because it builds upon itself with each cycle into an overwhelming advantage. One of my favorite quotes, "Ask me for anything," said Napoleon to his lieutenant, "anything but time." What Napoleon was saying to his subordinate was that there are always setbacks. Terrain is sometimes lost to the enemy, but lost terrain can be regained. Forces are lost in combat, but can be rebuilt and reconstituted. But lost time, once it has passed, time is lost forever. You will never see it again, and no general, however great, can win it back. This form of warfare, where you maneuver to gain an advantage, is called maneuver warfare. And this paragraph explaining the philosophy of maneuver warfare is from Marine Corps Doctrinal Publication 1, Warfighting, a masterwork of military doctrine. And I'm not just saying that because I was a Marine. It was published and adopted as the official warfighting doctrine of the US Marine Corps in 1989. Do you know what else happened in 1989? A man named Tim Berners-Lee submitted a proposal at CERN concerning information management, and this proposal would later become what we know as the World Wide Web. Another tenet of maneuver warfare is that war is both timeless and ever-changing. While the basic nature of war is constant, the means and methods we use evolve continuously. So it's the same today. The competitor that is able to adapt faster to the unforeseen events of the cyber war will be victorious. Only today, threats are no longer on the edges of our collective empire. They present themselves in our own houses, in our cars. Every device connected to our Internet of Things becomes an attack aperture. So whether it was Hannibal hacking through the Roman border gateway protocol, ALPS, or Rommel hacking his way through the French intrusion detection system, Maginot Line, or whether we're talking about the Great Firewall of China, which of course Genghis Khan laughed at in Mongolia, geographic location matters even less than before, and temporal advantage matters even more. Relatively slower, relatively static defense like cybersecurity with annual reviews is not going to survive. Which brings us to why DevSecOps is our best chance for survival today. DevSecOps is really an approach characterized by the disposition of our cyber talent for time-competitive cyber warfare. DevSecOps intrinsically regards time measured in velocity as a relevant metric of success. Now, looking at this cycle from the US DoD DevSecOps reference design, I really want you to pay attention to how much security is baked into the process. DevSecOps is not just the inner cycle without all of the security. In fact, just so we're all clear, maybe we should talk about what else DevSecOps is not. I hear a lot of people calling their development pipelines CI/CD pipelines, and yet they have zero cybersecurity built in. My question to my engineers is always, where are you delivering to and who enforces the cybersecurity? If it's just a development environment, or if it's just staging and not production, or, and God forbid, you're seeing a demo on localhost, then your engineers aren't delivering anywhere. You have a continuous integration pipeline. Nothing is getting put into production, and nothing is secure. DevSecOps is also not software as a service. Software as a service is building the software the traditional way in the cloud. In the US, it requires the product to be certified by a government program called FedRAMP, and it's limited to one classification at a time, mostly unclassified, or else it's developed entirely at its intended classification level, which probably means your engineers are in windowless rooms for 8 hours a day, every day. And this results in middling talent and middling results, because if you try to take a software engineer at the top of their game from Facebook, Netflix, Amazon, or Google, and tell them they're now restricted to a windowless room for their workday, you're not going to keep that top talent for very long. Importantly, software as a service takes well over a year to develop and deploy from an application to production. That's because software as a service uses the traditional risk management framework of cybersecurity. DevSecOps is very different from that. The annual reviews of traditional RMF are not time competitive. And as I hope we've shown, it's this piece that matters most. And it's the hard part, because it moves. It's not just a checklist that turns green, which means it's even harder for our non-technical customers to understand whether or not their system is defensible until they get hacked, of course, and then it's very, very easy for them to understand that their system was not. So our customers should understand this. Where the traditional risk management framework used by the US government accredits the code once a year, which is called an authority to operate, DevSecOps methodology accredits every single line of code as it is pushed, from hello world through every last merge request. This is called a continuous ATO, which uses automated testing and security. It exceeds the RMF, and it does it with every update. If we look at the platform like a factory, we don't accredit the software itself, we accredit the factory and the gates within, and then of course teams are authorized to use the factory. This is a picture from the Audi factory in Brussels, Belgium, which actually probably made a lot more sense when I was presenting this to NATO in Belgium. So making an analogy, we'd accredit the robots and the programs that drive the robots. In this way, we know that what comes out of the factory is accredited every single time. If there's any deficiencies, inspecting robots or gates would not let the car through. Our software factories consist of smart automation using tools that enable processes for rapid development and scalability. Cybersecurity functions and policy are enforced from inception through operations. By approaching mission applications this way, the DoD DevSecOps reference design brings a holistic cybersecurity stack, gaining complete visibility of all assets, software security state, and infrastructure as code. And this is what we mean by cybersecurity being baked in. The expectation is that every single line of code passes, no waivers, or it doesn't get deployed. The teams that are authorized to use the factory are made of DevSecOps engineers. And let's talk about them for a minute, because don't get me wrong, finding DevSecOps talent is not easy. What used to be done with 3 people, a software developer, a cybersecurity engineer, and a DevOps engineer, is now 1 person. So the coordination delays and communication errors are eliminated. It's all in one head using very powerful automation. Of course, they still have to understand that breadth of knowledge in order to use the tools, so these are senior engineers. But think about having a battalion operating at the cognitive speed 2 echelons below. Not just a company or platoon, a battalion operating at the cognitive speed of a squad. In short, what DevSecOps enables is the Silicon Valley approach. What version of Google search are you on, or any modern Silicon Valley-esque cloud-native application? They're updated many times a day. This ability to move fast and break things with cybersecurity built in from the first line of code opens up a world of possibilities when it comes to mission-critical applications. Mission applications can be managed as a service, deployed within secure cloud environments, including classified clouds on Kubernetes, and it can be accredited at multiple classification levels at the same time. DevSecOps enables rapid prototyping with delivery in days instead of a year or more, and at a tremendous savings in cost and a tremendous savings in time. It also enables responding to feedback in relevant timelines. In one case, my engineers were at a mission briefing at Red Flag, Alaska, and one of the operators turned to us and said, "You know what would be great if the tanker plan tool had a widget that did this thing?" Our engineers were able to implement that widget and push it into production before the end of that same mission briefing. That is the speed of relevance. And of course, when the operators see that, then the floodgates open. They start to feel invested in the application. Their ideas are actually being listened to and implemented. They can get the application they want and will actually use, not some application that doesn't get delivered until 3 years later when they're on their next assignment that nobody asked for and is already obsolete anyway. DevSecOps enables bug and security fixes in minutes instead of months. For example, twice during exercise Northern Edge 21, our on-site Alaska team was notified of a new 0-day, which meant they were required to include a patch for the 0-day in the next code update, or else it wouldn't pass the pipeline gates of the DevSecOps platform and therefore wouldn't be allowed to be deployed. So our teams made the proper patches to address a previously unknown 0-day within 3 hours. This should be the standard. Some real-world examples. Perhaps the most well-known of the developments I oversaw during my time at BrainGoo is a mission planning application for the US Air Force. Some, if you had known any pilots, they may have used it. It flew red flag in the last 2 years, and actually it's now used worldwide, including operationally and in theater. So we developed Widow from nothing, and that means 0 lines of code to actually in use on unclassified networks by the Air Force Weapons School, flying the largest air exercises the Air Force flies in 4.5 weeks, leveraging a continuous authority to operate. If I were to walk into your office and say I could deliver a production piece of software with government accreditation using traditional risk management framework in 5 weeks, you'd laugh me out of your office. But we did that with Widow, and we were designated the official mission planning cell application for the Air Force by week 8. It was deployed to a secret network in production by month 4, and top secret in production by month 6. 2 more examples on the screen. We've done this many more times as well, all with delivery to minimum viable product in production of less than 3 months. Each of these cloud-native applications available to anyone in the US Department of Defense worldwide with the URL and CAC authentication. Again, it's not just the speed of delivery, it's the cybersecurity piece that's hard. For instance, Audis are great products. I'm sorry, I didn't advance my slides. Here's the examples of the mission applications that I was just talking about. Widow on the left, 2 more examples on the screen. And now I'm talking about not just the speed of delivery. It's the cybersecurity piece that's hard. Audis are great products. They probably use a great agile process. They even have security built in, and of course that level of security is totally inappropriate for warfare. If you're not doing DevSecOps, you're entering the cyber battlefield in an Audi instead of an Abrams. So how can the rest of the US government easily and quickly adopt the Silicon Valley DevSecOps approach? Well, the United States has published our DoD DevSecOps reference design. This design was intended to do DevSecOps while avoiding vendor lock-in. It uses free and open source Kubernetes with cloud-native computing foundation and open container initiative containers. Okay, so when I was rehearsing, this is the point in my talk when my very smart, very educated, non-technical wife's eyes started to glaze over. So let's look at this a different way. This eye chart is the cloud-native computing foundation landscape. Each of these titles is a different tool or technology that performs a different function in the cloud. Some are very secure, some are not so secure. You could spend a long time trying to find a stack of these tiles to create a software factory that actually works well. And again, security, 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 nay, cyber warfare. A couple of short years ago, there were several innovation efforts. The US Department of Defense consolidated these efforts into one in order to save time, money, and resources. The result is Platform 1 and the DoD DevSecOps reference design. In other words, the DoD has figured out a very good, very secure path through the cloud-native computing landscape for you. These are some of the technologies that are used in this stack. Some highlights include hardened and centrally accredited containers, zero trust down to the function level using sidecar container stacks, continuous monitoring, continuous scanning, continuous penetration testing, scalable microservices architecture using Istio service mesh, and note that the architecture inherits 90% of NIST 800 controls and then uses hardened and centrally accredited containers on top of that. So some services that you may hear more about as you look into this: the DoD Centralized Artifact Repository, affectionately known as the Iron Bank, which is for hardened and centrally accredited containers, the basic building blocks of secure mission applications. Party Bus, being a multi-tenant DevSecOps environment where your mission application lives in an environment with several other organizations and you all share the time-competitive cybersecurity services. Big Bang is a single-tenant DevSecOps environment where your organization is the only one and the platform and the time-competitive cybersecurity teams work only for you. So hey, go ahead and DevSecOps reference design, have your team stand up a Big Bang, right? Obviously, it's not that easy to do. Kubernetes isn't even that old, and there just aren't enough DevSecOps engineers to go around. Fortunately, Platform One initiated a reseller program to help meet the demand. There are now 5 officially authorized Platform One resellers. Authorized resellers are qualified service providers of the Department of Defense Enterprise DevSecOps technology stack. They are herded by this lovely organization called Catalyst Campus out of Colorado, an innovation, collaboration partnership for private industry, academia, government, and allies as part of the National Defense Strategy. So for a customer, partnering with a reseller means rapid environment deployment and priority access to platform updates, new services, better security, continuous feedback, education and training, and continuing hardening. Platform One's technologies have been penetration tested by the NSA, Air Force, and Navy. DevSecOps is bleeding edge tech. Well, bleeding edge for the US government anyway. Silicon Valley wouldn't call this bleeding edge, and a lot of the ideas for Platform One came from the engineering stacks from the same companies. The engineering flaws. After all, the Agile Manifesto is now 20 years old. Meanwhile, we're still having a hard time getting rid of waterfall development, or what I colloquially call Agile fall, where they do waterfall but use Agile terminology. At any rate, Platform One assesses less than 1% like the US DoD has adopted DevSecOps. There are now, at the time that I wrote this, only a total of 4 US Air Force software factories with accredited continuous ATOs, which my team's built 2 of them. But importantly, that single-tenant DevSecOps platform environment called Big Bang is open source, which means anyone can adopt a comprehensive and holistic time-competitive cybersecurity posture quickly and through automated technologies relatively easily. So I will close with this thought. Why is adopting a time-competitive cybersecurity posture through DevSecOps critical to United States survival? And the answer is simple. Our adversaries are already mastering this. Thank you very much.
There's time for questions if you guys have any questions.
Few minutes for questions. I've recently done that. In the front.
I don't know where to start. I think I'd like to hear what you think of DevSecOps and the applicability for the cloud and how organizations can tackle that. Because I think when I think of smaller modular teams, I wonder if they see the full scope of everything themselves. So that's another I'm trying to so I'm curious.
Yeah. So actually, one of the reasons I like Platform One, especially what you're talking about, sounds really akin to Party Bus, where you have the core team of facilitators that have built the DevSecOps infrastructure, and the cybersecurity services are provided for that infrastructure. And so they're doing that really specialized technical cybersecurity work. And it sounds like what you're talking about is perhaps a small team that wants to build an application, and they learn how to build software in the factory. And now they're just responsible for building the software that they want and making sure that they meet all of the constraints of the factory in order for their software to make it through the CI/CD pipeline and all the security constraints and into production. And so what you're looking at is a small team that's trained on, or actually would be authorized to use the factory. And then once they're authorized, it's all automated. So they can move at their fastest natural pace. They can push code multiple times a day. It's all going to be automated in the CI/CD pipeline. So I think that the design, it centrally accredits what needs to be centrally accredited by the specialist, and then it enables teams to run at their fastest pace, so long as they're meeting all the cybersecurity. Yeah, and let's see. Go ahead, sir.
So you mentioned that there's a group of DevSecOps engineers areas in the world. So are there places, resources, things you would recommend?
Yeah, that's a really good question. It's one of the toughest things is finding really good DevSecOps engineers. I will say that there are now, Kubernetes is a few years old now, and you are starting to find them in the workforce available in the marketplace. We found really good success by taking DevOps engineers and then turning them into DevSecOps. So DevOps engineers, and then we basically have them go get their like certified Kubernetes administrator, certified Kubernetes developer. The thing about DevSecOps in general, like Kubernetes is a good example. I mean, Kubernetes today doesn't look like Kubernetes 6 months ago. It's not going to look like Kubernetes 6 months from now, right? So it's a constantly evolving technology. And I think when you're talking about DevSecOps, that's really the name of the game. It goes back to that time competitive attitude. So all of these DevSecOps engineers have to be continuously learning. And I think that that's just so important for the DevSecOps team. You have to be continuously learning about the next technology, about the next attack, about the next exploit, the next vulnerability. What's the new security layer we need to add that looks for this new classification of attack? I heard a new one today about push notification exploits that Brad wrote. So that was new. Yeah. I don't know if that answers your question. We found some success in taking DevOps engineers and turning them into DevSecOps engineers. That's, but, it really only worked when you have these like really knowledgeable like DevSecOps engineers who are like really pushing the technology, like pushing upstream fixes of, Kubernetes and stuff. And they can help mentor and teach. But ultimately, it's a new technology, and we just got to all dive in and learn it because it's that important. That's my little bit of opinion there. Go ahead. Cheers.
How did you find success with working with traditional acquisitions and moving and getting them, like acquisition professionals who've been doing this and, JSIDs and everything else for 20 years, and getting them to know that the acquisition pathway, the software acquisition pathway, is a thing and we can shorten this time and it's okay to do this now, and to get them to understand and grok like the intent behind choosing the
new
conversation
I was having over lunch, yeah. The technology part's relatively easy. You use a strangle approach, like you're probably familiar with. You have a load balancer that redirects to the new IP, and you can just kind of choose those parts of your application that's going to become DevSecOps instead of like relatively easy, standard stuff. It's always the people that's the hardest part to convince. So DevSecOps, I think most of you probably heard of Nick Shalane, when he was the Chief Technology Officer of the Air Force. He did a really good job. I think he's Chief Software Officer of the Air Force. He did a really good job of pushing this. There's memorandums out there. Platform one is supposed to have reciprocity with the rest of the DoD, but it always comes to the people whether or not they're willing to get it, mostly because they don't understand it. And I've been on a conference call with the Chief Software Officer of the Air Force, an acquisitions officer up in Alaska, their JAG, and the acquisitions officer was trying to tell us that this is an illegal way to build software because it's not in accordance with the publication of how DoD acquires software, which is waterfall, right? And so we're like, look, here's the memorandum signed by the Secretary of the Air Force. Like, you can build software in this way. It's both operational and development. Yes, at the same time, it can take any color of money. And they're like, no, we're not comfortable with it. It's always the bureaucracy and convincing the people because it's a new approach. And that's why I'm giving this speech. I'm trying to build awareness. I'm trying to explain why it's so important and that the technology already exists. A lot of people were also, we saw that slide with all the innovation hubs. A lot of people were kind of doing this on their own. We say, hey, let's all do this together. And so now we have 5.1, we have unified platform. And there's still organizations who are just hearing about it and trying to do it on their own. They haven't even heard of it.
So to caveat on that, I went to the Air Force at the base, and I can tell you that obviously the base itself, it's all like closed hold information, it's all hold everything together, and like even though I get the memorandum from it's a cheap thing, this is authorized for software, right? Do what? Do some writing. It's in writing.
Yeah.
No, they won't accept that.
Yeah, big part of it is the customer doesn't understand the technology. That's a real big part.
Hey, wait, why do you think the adversary is good?
Yeah, they're not restricted by our bureaucracy, right? So like if you look at China, for instance, it's a very top-down, organization. So they can say, hey, you're going to do this thing, and then they go and do it, right? So they're coming from they're the underdog who needs to figure out a way to defeat us. So they can take these unconventional approaches, whereas our, like everything else that they've developed in a third of the time that it's taken us to.